Next up is our lesson on scale factors. So title's already there. Get your information in the top right hand corner, your name, your class period, and the date, and then fill in your essential question. How can you use a scale factor to find the length of an object? All right, sorry about that. So first part is scale drawings and scale models. What are we talking about? These are used to represent objects that are either too large or too small to be drawn or built at actual size. So an example here is our Ferris wheel. We want to be able to draw a picture of this Ferris wheel to scale, but obviously you can't fit the entire Ferris wheel on a piece of paper. So we use a scale that gives the ratio, remember ratio is a fraction, that compares the measurements of the drawing or model to the measurements of the real thing. So down here we have our scale. 0.5 centimeters, so half of a centimeter, in our drawing is equal to 1.5 meters in real life. And this real life object is 36 meters tall. So we want to use our scale factor to figure out how tall would we draw this model if we were to create a model at a 0.5 centimeter to 1.5 meter scale. Well, to do that, we just set up a proportion. It's something we've gotten very good at. So anything related to the scale drawing goes on top. Anything related to the actual drawing or the actual item goes on the bottom. And a lot of times your units are going to help steer you in that direction. But you just start by using your scale factor. 0.5 centimeters, so 0.5 centimeters on top, to 1.5 meters. Now we look at the other piece of information. In our diagram here, it says that the total height of this Ferris wheel is 36 meters. Since we're dealing in meters, that must mean it's our actual measurement, which makes sense. You couldn't fit 36 meters on a sheet of paper. So the meters is going to go on the bottom because it's talking about the actual size, and we want to put the x up top. That's the piece that we're missing. And then all you do is you solve your proportion. You do your cross products. 1.5 times x is 1.5x. 0.5 times 36, well, 0.5 is really a half, so half of 36 is 18, and then we solve. Divide both sides by 1.5. X is equal to 12. We're dealing in centimeters, so it would be 12 centimeters tall. So this Ferris wheel that's 36 meters tall in real life, based on our scale, we would draw it at 12 centimeters high on our sheet of paper, something that you could reasonably fit on a regular sheet of paper for us. So let's see a couple more. In each of these problems, we're going to be given our scale factor. That's what you start with. 2 inches in our model is equal to 15 feet on the real object. And then we're given one more piece of information. In this case, 87 feet is the length of our airplane. Clearly that's not the length of our model, so that must be the length of our real airplane. And again, 15 feet is on the bottom, so it makes sense that 87 feet is going to be on the bottom over here. So what we want to know is how long should we draw our model if we're using 2 inches to represent every 15 feet? Well, find your cross products. 2 times 87 would be 174. 15 times x is 15x. Divide both sides by 15. You're just solving your equation. And x is equal to 11.6. We were dealing in inches, so we label it as 11.6 inches. So if we were to draw a model of this airplane at a scale of 2 inches representing every 15 feet of real length, it would need to be 11.6 inches long. So, next one. If you think you've got it down, go ahead and give it a try on your own, but if not, follow along as I do it. Start with your scale factor. 1 inch is equal to 5 miles. Then they give us one more piece of information. It says, if the city is 5 1/4 or 5 1/5 inches across on the map, what's the actual distance across the city? Well, 5 1/5 is the same thing as 5.2. Remember, 1/5 is the same thing as 2/10 or 0.2. But that's inches on our map. Well, That's our scale drawing, so that's going to go on top. Inches is on top. We want to know how big is it in real life. So we solve our proportion, multiply along our diagonals. 5 times 5.2 gives us 26. 1 times x gives me 1x, or x. So x is equal to 26 miles. So on a map that says 1 inch represents 5 miles, if a city is 5 1/5 inches across on the map, so that's how big it is when it's drawn on the map, in real life it would be 26 miles in size. So it's really all about setting up and solving those proportions. Next part, to find a scale factor. What that basically means is we want to write the ratio with the same units and in simplest form. So basically a fraction that can be represented in simplest form. So this one says 1 inch is equal to 6 feet. So we start with 1 inch and we go to 6 feet. But the first thing it says is we need to change it to the same units. So since we're dealing in 1 inch, let's change feet into inches. So how many inches are in 1 foot? Well, there's 12 inches in 1 foot, but I have 6 feet. So I have to do 6 times 12, because there's 12 inches in each foot, and that gives me 72 inches. And here's my 1 inch. So now I have it in the same units. Now I look to see if I can simplify it. Well, 1 and 72 can't be simplified any farther, so I leave it as 1 over 72. So I leave it without the units, and I leave it in simplest form. So let's try the next one. 5 centimeters to 1 meter. But the first step is we got to rewrite them with the same units. So we have centimeters, so let's change meters into centimeters. Remember, there are 100 centimeters in a meter, so we can multiply times 100, and we get 100 centimeters is the same thing as 1 meter over 5 centimeters. And then we simplify. 5 and 100 can both be divided by 5, and we get a scale factor of 1/20. So 1 centimeter in the model is equal to 20 centimeters in the real object. So see if you can handle this one on your own, but if not, follow along. So 4 inches over 2 yards. First thing we need to do is change it to the same units. So let's switch from inches to change our yards into inches. Excuse me. There are 36 inches in 1 yard, 3 feet, but each foot has 12 inches, so 36 inches. So we do 2 times 36, which is 72 inches. This one was already in inches, so we leave it in inches. And now we go to simplify. So we've changed our units. Now we get rid of our units and we simplify. 4 over 72. Well, those can each be divided by 4. And I get 1 over 18. So I have a scale factor of 1/18. So let's put all of this together. It says Tyson is creating a scale drawing of the area of his school. The rectangular drawing shows the length is 20 inches and the width is 19 inches. So let's kind of sketch this out here. So the width is 20 inches and the height is, or the length is 20 inches and the width is 19. That's our base and our height. The drawing uses a scale of 1 inch equals 3 feet. So we want to know what's the actual area of the school in square feet. So basically we want to go from our model to a full-size version, a bigger version of the schoolyard, and then we're going to go ahead and find its area. So we need to convert each of our units using our scale factor, and then we're going to use that to find our area. So start with our 20 inches. We know it's 1 inch for 3 feet. We have 20 inches, so we want to know how many feet. Well, we multiply. 3 times 20 is 60, is equal to 1 times x, or x. So I get 60 feet. That's my base. Then I do the same thing with my width. 1 inch to 3 feet is equal to 19 inches over something. 3 times 19 gives me 57. 1 times x gives me 1x, or just x, so I get 57 feet. So I've converted each one of my units into their new actual measurements based on my scale, and now I go ahead and find my area, which is really just base times height. So I do 60 times 57. Let me clean that one up. Oop, I'm just going crazy on me now. So 60 times, almost did it again, 57 is 3,420. Bonus points if you know the correct units to put on here. Since we're finding area, since we're measuring in feet, it would be feet squared, because it was feet times feet, or feet squared. So we used our scale to convert the units of our model, our drawing, to the real measurements, and then we use those real measurements to calculate the area of our schoolyard.